Opening scene, calm background music, on-screen title. Understanding, FSM, basic machines, properties, limitations, more, and Mealy models. Narrator, voiceover. Welcome to today's lesson on finite state machines, or FSMs, a core concept in computer science, digital logic design, and automata theory. Let's break it all down, simply and clearly. Part 1. What is a basic machine? Slide. What is a finite state machine, FSM? Narrator, voiceover. A finite state machine is a computational model made up of a finite number of states, inputs and outputs, transitions between states based on inputs. FSMs are used to model systems where the output depends on current state and input, like vending machines, traffic signals, or even simple software logic. Part 2. Properties of FSMs. Slide. Properties of FSM. Narrator, voiceover. Some important properties of FSMs include determinism. Each input leads to one specific next state. State transition function describes how the machine moves from one state to another. Finite memory. FSMs do not store past inputs. They only rely on the current state. Initial state. Every FSM begins in a defined starting state. Accepting, final states, in accepting machines. Some FSMs use final states to determine valid input sequences. Part 3. Limitations of FSMs. Slide. Limitations of FSM. Narrator, voiceover. While FSMs are powerful, they do have limitations. No memory of past inputs beyond the current state, can't handle nested or recursive structures, struggles with complex languages like context-free or context-sensitive languages. FSMs are best for simple linear logic, not for problems needing memory or complex hierarchies. Part 4. Moore versus Mealy machines. Slide. Moore versus Mealy machines. Narrator, voiceover. There are two main types of FSMs, Moore machines and Mealy machines. Moore machine, visual state circle labeled with output, e.g. S1, 0. The output depends only on the current state. Outputs change only when the state changes. Easier to design, but may need more states. Simple, predictable output. Slower response to input changes. Mealy machine. Visual, transition arrow labeled with input, output, e.g. 1, 0. The output depends on both the current state and input. Outputs can change during transitions, typically requires fewer states. More responsive, compact design. Slightly more complex logic. Which one to use? Narrator, voiceover. Use Moore machines when you want stable outputs tied to states. Use Mealy machines when you need faster output reactions to inputs. Recap. Slide. Summary list. Today, we covered what is an FSM properties and limitations Moore versus Mealy machines. Closing scene. Thank you screen. Narrator, voiceover. Thanks for watching. If you found this helpful, don't forget to like, share, and subscribe for more clear explanations on computer science concepts. Keep learning and keep building smart systems.